So, before experiment we have to make sure that vertical axis of rotation and the horizontal axis of the telescope and collimator they are perfectly positioned. Okay. So, so for that basically we have to go step by step, So, first leveling of telescope. What is the purpose? Purpose is to make rotational axis vertical and telescope axis horizontal. Okay. So, for this we use the spirit level. So, keep the spirit level along the tube of the telescope. Okay. And here it is telling that adjust two base leveling the screw below the collimator, leaving the screw below the collimator. So, base level, this is the base level. Okay. So, there are two leveling screw, base leveling screw, and third one is here below the collimator. So, leaving this one, you use these two leveling screw, base leveling screw, to bring this one at the middle. So, it is already almost it is in middle, So, if it is not exactly in middle, then you should rotate this one in opposite direction, So, if I rotate this clockwise, this is the clockwise, and this I should rotate anti-clockwise. Okay. So, this way you try to bring them, you have to check whether it is moving in middle or this other side. So, I can see it is moving in other side. So, I have to rotate in opposite direction. Okay. So, it is more or less it is in middle, So, this way you have to bring this air bubble at the middle. So, then rotate the telescope by 180 degree and adjust the base and telescope leveling screw. Okay. So, next step is telling that you rotate the telescope at 180 degree, almost 180 degree, you cannot make it exactly 180 degree. Then put again this one here. Okay. Now, to bring it at middle, so you have to adjust basically again these two, this adjust base and telescope leveling screw. Okay. These two you can adjust, as well as these two you have to adjust. So, it is more or less at the middle. So, I am not disturbing much. So, I think I have to bring it middle. Yeah. Okay. So, it is more or less in middle. So, this way you just repeat the operation, again bring back and check it whether it is in middle. If not, then you can adjust this, take back there, just 1 to 3 times, just you can try and keep it in middle. Okay. So, now this way, this your telescope, this axis is horizontal and the axis of rotation of the telescope is vertical. Okay. So, place the telescope in same line of the collimator. Now adjust the base leveling screw below the collimator. Okay. So, if necessary you keep in same line, and then if you see that it is not exactly in the middle, if you need to adjust slightly. So, you have to use this leveling screw, base leveling screw below the collimator. But here this one is fixed, we cannot change. So, keeping it fixed, so you have to adjust basically other two screw and the telescope leveling screw. Okay. So, next, after leveling the telescope, you have to go for leveling of the collimator. So, collimator, to make collimator axis horizontal, place again just it is simple, place this one in middle, and then just adjust the collimator leveling screw. So, I will not disturb this one, this base leveling screw I will not disturb anymore. Okay. So, this one also I will not disturb anymore, it is leveled. So, here you can do leveling just adjusting these two. Here already it is in middle, so I am not disturbing. So, if necessary to bring this middle, so use this leveling collimator leveling screw. Okay, bring it at middle. Okay. So, now your whatever requirement I told, that part is done, that is the leveling, that part is done. What was the requirement I told? This requirement was the axis of rotation of telescope should be vertical, axis of telescope and of that of the collimator should be horizontal. Now, next that part is done. Now, top of the prism table should be horizontal. Okay. Next part is leveling of the prism table, leveling of the prism table. So, here I will not disturb any other leveling screw, only these three are left, this prism table, these three are left. So, here basically on prism table, so these leveling screws, three screws, they are connected. Okay. So, keep the leveling spirit level, so parallel to the one connecting line of the line of the leveling screw. So, this way you place. Now, you adjust these two, bring it in middle. So, it is in non middle. So, again this also I have to rotate in opposite direction. I have to rotate in opposite direction. Okay. So, basically other way I have to rotate, yeah, opposite direction. I am rotating in opposite direction. Yes, it is in middle. Now, it is in middle. Okay. So, then we have to put this one, in a the same line in vertically, same line we will put vertically, and then we will adjust this screw, leveling screw, to bring it at middle. So, other way I have to rotate to bring it in middle. To bring it in middle. So, repeat the process once more. You see this, once more you see here, this is almost in middle, and this way you see it is almost in middle. Okay. So, this way you have to repeat the operation and bring this then this table is perfectly horizontal. Okay. So, I have not disturbed any other labelings too, only for prism I have used this. So, now prism table is horizontal, fine. So, this way this called basically mechanical labeling. So, after this mechanical labeling, what are the next step? You will go for the next step. Next step is adjusting cross wire and focusing image. Okay. So, already I have showed you this: rotate the telescope towards any illuminated background and move eyepiece towards inwards or outwards until the cross wire appear distinct. So, that part already I have done. Okay, I have showed you. Next, place the telescope in line with the collimator, make the image sharp by turning the focusing knob of the telescope and of the collimator. Place the telescope in line with the collimator, make the image sharp by turning the, so basically you have to see this image. Okay, you have to see the image, and it is telling that make it sharp using these two. Yeah, I have make it sharp. So, you can see the image of the slit. This is the image of the slit for our source. Okay. So, you can see the crosswire and this image. So, adjusting the just focusing knob of the telescope and the collimator, you can get the sharp image. But here this is the approximately we have done. This is approximately we have done just to see the image basically, but we have to, for getting the parallel rays, there is a method. So, that method we have to apply. So, that I will apply later on. So, this way we adjust the crosswire and focus the image as I showed you. Okay. So, if image is not vertical, then you have to turn the slit and make it vertical. Okay. So, there is a scope of turning the slit in its own plane. So, you can make it vertical. Crosswire also I have put here in cross position. So, you can put also in plus position. Okay. Just rotating the crosswire. So, there is a scope. Okay. So, now basically next we have to go for optical leveling of the prism. So, things are already leveled, but why we need the optical leveling? Now, question is to make refracting faces of the prism vertical. Now, this is the prism. Okay. If this prism, this surface is perfectly smooth and horizontal, so then I do not need to do the optical leveling. Okay. Or when we will use the grating. Okay. So, grating surface, getting this base may not be perfectly horizontal. So, if it is not perfectly horizontal, so that means there will be some tilting. Okay. So, that part, so to make it this refracting surface, what is the refracting surface? This is the refracting surface, So, this refracting surface has to be vertical on the prism table. So, that is the condition, So, if it is not, this base is not perfectly horizontal, if any up down is there, so it may have some tilting. Okay. It may have some tilting. So, for that what will happen, this whatever image will get. So, that image one side it may go down and other side it may go up. So, that is why we have to do this optical leveling. So, that image in all side we get on the same in the middle of the view. So, it is telling that we illuminate the light, sodium source use. So, already we have sodium source. Okay. Place the telescope at 90 degree with respect to the collimator. So, place the 90 approximately, if I place at 90 degree, okay, with the collimator, okay, with the collimator. Place the prism on the table, with its vertex coinciding with that of the top table, okay, and with one of its faces perpendicular to the line joining of the leveling screw of the prism table. So, what it is telling? So, in prism, let me tell you what is there. You see, in this prism, it is a basically triangular prism. So, it has two triangular face. Okay. This is one triangular face and this is another triangular face. Okay. And the other three faces are rectangular. So, here these two triangular face and that other one rectangular face, they are basically opaque, they are not transparent. Okay. They are not transparent. So, out of three rectangular faces, one is opaque, okay, non transparent, and other two rectangular are transparent. Okay. So, these two we tell the refracting surface. Okay. So, now here this base of this prism is basically this one, okay, non refracting surface. Okay. So, this opaque surface, this one is the base. So, these two are transparent and this we tell apex, or this we take as a prism angle. Okay. Apex angle, prism angle. So, it is telling that place the prism on table with its vertex, means this, with that of the prism table, with the vertex that of the prism table. So, means this vertex will make it at the center, this vertex at the center of this prism, center of the prism table. Okay. And with one of its faces, these two faces, okay, refracting faces, perpendicular to the line joining of the leveling screw of the prism table, and then you keep at 90 degree, see the image, I can see the image, and it is I can see the image. So, if image is not in middle, so these two screw, whatever these two screw, you have to rotate in opposite direction. Okay. So, it is more or less its level. So, I am not rotating. So, in opposite direction you have to rotate and bring this image at the middle of the field. Okay. Then you take the reflection from the other surface, so this surface, okay, and see it, I can see it. I can see it. So, basically now this one, the third screw, you have to rotate to bring it in middle if it is not in middle. So, it is more or less in middle. I do not want to, so slightly I can take down, okay, slightly I can take down. Okay. So, this is the optical leveling. Okay. So, I am getting the view for both from both surface, refracting surface, I am getting the slit image at the middle. Okay. So, I am not showing that one in the camera. So, next, so this spectrometer is now completely leveled. Okay. It is ready for the experiment. Okay. Now, for the experiment, this so this for optical leveling. So, this you can repeat from the for the both surfaces as I mentioned. Now, for experiment, as I told that you have to go for the some method for getting the parallel rays, Okay. So, that basically for getting focusing or focusing for parallel rays. So, there is a method, it is called Schuster's method, focusing for parallel rays by Schuster's method. Okay. So, so this is one method. I think I will describe this method. Yes. Before that, let me tell another simple method to make to get the focusing for the parallel rays. So, the simple method, what is that? So, let me take it out. Okay. So, first what we have to do for parallel rays. So, here eyepiece is set at the distance from the crosswire in such a way that crosswire is focused. That means, crosswire is at the focal point of the eyepiece. Okay. Now, this crosswire I have to put exactly at the focal point of this telescope lens, right. So, for that there is a Schuster's method. So, here another simple method I will describe, that is, if you what I need parallel rays are falling on the telescope, and that parallel rays will be converged on the focal plane. Okay. And there will be formation of image, and that image of what, from where that light is coming. Okay. And then there at that focal point where image is formed, so I have to put the crosswire. Okay. So, now you know from distant object, okay, from distant source, from long distance if light comes. So, we take that light is coming to us as a parallel rays. Okay. So, here if I take a distance object, say in this lab, if I take this, the distance lab, that is the almirah. Okay. If I focus at this almirah, this long distance there. Okay. So, I can see the almirah, okay. It is almost focused, okay. So, I will focus. So, from almirah it is long distance. So, here this whatever light entering into this lens, that is the, then we tell that is the parallel rays. So, these parallel rays are coming, and then image will form at the focal point. I have to put the crosswire at the focal point. So, that is why I have to make that image sharp. I can make the image sharp. Yes, there is a write up there. Yes, I have make the write up sharp. Okay, that means my crosswire at the focal plane of the telescope lens. Okay, so that way distance object if we focused, then and we can see the sharp image of this distant object. That means the crosswire is at the focal plane of the telescope lens. Okay. So, that is the purpose for this setting of this telescope for parallel rays. Okay. So, in this case we assume that from the distance object the rays are coming here, when it is reaching to the telescope rays are parallel. Okay. Now, but this we are not going to, so then we will not disturb. So, let me just check once more, it is the whether I need slightly any, because that was in different eye. So, in my eye I have to check sharp image I can see. Okay. So, now we will not disturb this knob, because this is set for this focusing knob. We have set the crosswire at the focal plane of this lens. Okay, in this way. Okay. Now, this parallel light is not coming from this source, right. So, we have to make, so here we have to see this now direct light, we have to see this direct light. Okay. And so, since it is not, this source is not at infinity, not at very distant place. So, this knob we have to adjust to keep this source at the focal point of this lens, then whatever light will come, that will be parallel. So, then we will see the very sharp image. So, this image is almost sharp, because already earlier we adjusted. So, now you have to adjust this one to make the image of the slit is very sharp, to make the image of the slit very sharp. Okay. Yes, it is sharp. It is sharp, and I will redo slightly, make it slightly thinner. Okay. So, I have made it, I am not showing you, but to make the sharp image, okay, as I have seen at infinity that distance one. So, to get this type of sharp image, I have to adjust the collimator focusing knob. So, that means the light is coming from the collimator. So, that is parallel rays. So, this way we have to make the parallel rays coming from the collimator, and here this parallel rays entering into this telescope lens, and they are meeting at the focal point of this one, and there we have put the crosshair. Okay. So, that is the basically focusing for parallel rays by a method. This is the simplest method. Another method is there, that is called Schuster's method. I think I may discuss this one. So, one has to go step by step. So, let me stop here. Okay. So, now actually this setup is ready for the experiment. Different kind of experiment one can do, okay, using the prism. So, that one by one we will discuss in coming classes. So, in next class basically I would like to show you the Schuster's method. This very famous method to make the parallel rays. So, step by step we have to follow that method. So, in next class I will discuss this method. Okay. So, thank you.